Good afternoon, my fabulous chemistry students. Unit number 4, bonding, video 1. We're going to do a little review and talk about energy. Basically, we need to wrap up some of the things we've already learned in the past 2 units because they're all going to come into play in this unit. And then we're going to get into exo and endothermic processes. So why do atoms bond? Atoms do bond to form a stable compound at a lower energy. So all things in nature want to be at a lower energy, which is more stable. Quick review. A compound is 2 or more different elements. Okay, a bond is a force of attraction between the proton of one element and the valence electrons of another element. Bonds are formed as a result of a chemical reaction. When I'm done, it's not the same thing. I have hydrogen, I have oxygen, I bond them together, I now have water, I have something different. So it's a chemical reaction. Conservation of energy, mass, and charge. I think of course, we'll do mass first, and then energy, and then charge, the way we have designed the units. But basically what it comes down to is I cannot create or destroy energy, mass, or charge. It has to be conserved, which means it can be transferred in one form or another. Now, 8 is great. The octet rule, octet, octopus. Oct means 8. So we like to say 8 is great, right? We want 8 valence electrons to have a full valence shell. Okay, and that's going to come into major play with bonding. Okay, so it says here, which noble gas, helium, neon, argon, or krypton would most likely form a bond with another element? Well, we have learned that the noble gases do not form any bonds. But if I look down here at Kr, it sometimes can form an ion. So if one of these was going to bond first, it would be Kr. Why do you think that is? It has an oxidation state of 2. Okay, and it's not the first oxidation state, it's the second oxidation state. So does it normally form a bond? No. Extreme circumstances could make it happen. Which elements, Na, O, F, P, or S, would most likely form a bond with Kr? Well, who wants 2 electrons? I see oxygen and sulfur both want 2 electrons. Why do you think that is? They both have -2 oxidation states. Or want 2 electrons. Okay? Energy and bonding. So we need to understand spontaneous. That's a very good vocabulary word. The bond formation is released. When I form bonds, energy is released. I will go from a high energy to a low energy. Okay, this creates stability. Spontaneous means it goes by itself. It's not so much quick as it is it goes by itself. I don't have to push it. It's just going to want to go from high energy to low energy naturally. Okay? Exothermic. X usually means exit. So energy is released. You'll see that it's on the right-hand side of the equation. When we get into physical behavior of matter unit, we're going to start studying this a little bit more in depth, I promise. Energy is on the product side, right? It's on the right-hand side, so therefore it is being released. I would be able to feel it if it was happening. An example is this big bad equation that we'll learn how to do these equations later. Yes, this is coming right here. Writing and balancing equations. Can't wait. Heat is on the product side, so that's exothermic. Breaking bonds, of course, is not spontaneous. I have to give it energy to make it go. Energy is consumed. I'll go from a lower energy to a higher energy, which is not very happy. Okay, ripping the 2 apart takes energy. I have to heat it up generally. Endothermic is the opposite. So endothermic is when energy is consumed, which we just talked about. So now, of course, energy is going to be on the reactant side. We'll get into reactant and product when we get into equations, okay? It's on the reactant side. Think of an ice pack. Chemicals combine, bonds are broken, energy is consumed. You feel the cold. So now we know a little bit about exothermic and endothermic reactions. It's just important to understand that when I make a bond, I go to a lower energy. Okay, so I am exothermic. I give off heat. That's really the key for today's lesson. Okay, you're gonna have a lesson quiz on energy and chemical reactions, of course, and don't forget to sign up for our text now if you haven't yet. See you guys tomorrow in class.